usually say good evening, everyone, but good evening, sir. I'm going to call to order the State of Rhode Island Coastal Resources Management Council semi-monthly meeting to order. Today is Tuesday, April 23, 2024. I would ask that the record reflect the council members that are present as well as staff members that are present here this evening. Our first matter on the docket is approval of minutes of the previous meeting, that being April 9, 2024. I know they've been disseminated to the members. If there's no proposed corrections, I would entertain a motion to approve if you are so inclined.
Motion to approve.
Motion's made by Mr. Flynn. Is there a second? Second by Mr. Gomez. Any discussion? Hearing none, all in favor say aye. Aye. Anyone opposed? Meeting minutes are passed and accepted unanimously. Subcommittee reports, Mr. Willis.
Mr. Chair, there's one subcommittee report. The Rights of Way Subcommittee met earlier this evening and had a status update on the Spring Avenue extension matter down in Westerly. What was agreed to was a fifth proposed revised schedule that has a date certain of June 15th to provide documentation on the agreed upon facts and travel of the matter. That was approved by the subcommittee. So that matter, the Spring Ave matter for the subcommittee, will have a date certain and be able to move forward with the evidentiary hearing shortly after that.
Thank you. Any questions of Director Willis? Anything else subcommittee wise?
No other
All right,
subcommittees.
staff reports.
Just a couple of announcements, Mr. Chair. We are partnering with the Department of Environmental Management and the Research Reserve in the town of Westerly on purchasing with bipartisan infrastructure law and Inflation Reduction Act monies to purchase a property down in Atlantic Ave in Winnapogue area. If you all remember the old water park down in Squamicut, that parcel is being purchased under those federal bills and will become open space for State of Rhode Island town of Westerly. We are also partnering with DEM and the Infrastructure Bank on the ability to competitively award $4 million in grant municipalities for shoreline resistance projects. Also includes habitat shoreline access projects as well. That's an open process right now. Again, that would be a competitive process. One of the things that CRMC is doing to further its rights of way mission is, as you all know, we have perpendicular rights of way responsibilities to the shore, and we've put up marker posts and signs at many of those rights of ways that this subcommittee and this council have designated. What we've done is try to come into the 21st century and use technology to get information out on all of those by going to each one and placing those QR codes on the actual rights of way placard. And that, if you take your phone and you scan the QR code, you will be led to our website, which has more information on rights of way. And then in particular, you can get information on the right of way where you're particularly at. You can get general information on public trust. You can also look at our interactive rights of way map on your phone and also learn about all the other things we're doing with public access. So it's a good outreach effort, and we're just starting now. We just literally got the QR codes last week. So staff is going out into the field and placing those on the marker posts and signs. And then lastly, I was in front of both the House and the Senate Finance Committees 2 weeks ago now. And in front of the House committee, I was asked a specific question on what are we doing with the Washington Bridge? And so I just had to explain, well, we're a regulatory agency, and I explained our role and how we're working with Rhode on basically being at the ready whenever they need us, when they get information or need to have plans reviewed for the project. And one of the reps said, well, can you put on your website status updates on what you're doing with DOT on the Washington Bridge? The rep felt it was important that even though CRMC doesn't have a direct role in getting that bridge up and operable, we do have a role. And so we are putting on our website that type of status report, and we've posted one already. Laura's done a great job of just basically letting folks know that we're at the ready to help DOT move this issue forward as soon as we can. So just want to let the council members know what we're up to. Thank you.
I have a question.
Sure.
On the second infrastructure money comment that you had, on the one that was competitive? You said there was some funding,
With the infrastructure bank and
Yeah.
DEM,
yeah.
that's the MRP program.
Yeah, and what's that for exactly?
It is grants for adaptation and resilience projects that protect or enhance coastal or riverine habitats to address the impact of climate change. But it's limited to projects on public lands.
Okay, so does it ever include beach renourishment?
I don't think it goes into that detail, but it does allow for public access. So if your access project has that component, it might be worthy of the competition.
Okay, so but if you're just doing beach renourishment, for example, that would not be qualifying for those funds. I'm just wondering about whether when we are in those situations when funds are passing through us relative to particularly municipalities looking to do work relative to responding to climate change, infrastructure, modifications and resiliency and all that, are we conditioning that on having an avenue for public access being maintained in those situations? Because as a condition of receiving public funds from the government, which serves all, is there a way that there's a condition where access is a condition upon receiving those types of public funds?
Well, I would think that would be part of the ranking in the competitive process. So if the project had that, a nourishment project that offered public access, it might rank higher than one that did not. I know where you're going, and I understand nourishment, especially when you are adding depth to a beach face, and you're maybe adding depth that enters the public realm. And so if you're going to take public monies and you're going to take public resource, the public has to have the ability to use that area too.
Right.
I understand.
Any further questions of Director Willis? Okay. Brings us to number 4 on the agenda, coastal education series. Discussion to be held regarding structural health monitoring programs of operational offshore wind facilities in the United States. Presentation by Dr. Chris Baxter, University of Rhode Island, and welcome, Dr. Baxter.
Thank you. Again, this is Dr. Chris Baxter, who, and with David Ciochetto, one of our ocean engineers, and other members of his team that Chris will talk about in general with Tufts University and others. Their important research on the structural health of wind farms in the environment that we have here is something that was spearheaded and discussed about when we were looking at Block Island, quite frankly, those many years ago. It's resulted in this long-term effort that I think is gaining speed. And Chris, if you can talk about that, the future, this looks pretty exciting, but we're very much looking forward to hear where you're at right now with the project and where it's going. So please come on up and we'll trade places.
We will trade places.
Yeah.
So yeah, thank you, Jeff, and good evening, everybody. I appreciate the invitation to come and talk to you about some of the work we're doing at URI. Again, my name is Chris Baxter. Just give a little background. I'm a professor in both the ocean engineering and civil engineering departments at URI. This is my 25th year here at URI. I'm originally from New Bedford, Massachusetts, but I moved up here from Virginia 25 years ago, specifically to work within the ocean engineering department. And have loved almost every minute of it ever since. It's a fabulous group. And I think we produce really good students, and we're really proud of our graduates and of our research. And so what I'm going to talk to you today about is our work that really is born out of CRMC to do structural health monitoring at a couple of wind farms in the United States. And up until this year, we could say that Rhode Island had instrumented all the wind farms in the US. South Fork and Vineyard Wind are sort of putting a dent in that, but you'll see we're doing a lot of work right now. As you can see, can you guys see? You want me to step back a little bit? Okay. So, and I want to acknowledge my colleagues. Dave Ciochetto is the lead over the overall project. The project is funded by BESI. You'll see that in a second, the Bureau of Safety and Environmental Enforcement. And we were tasked with putting a team together. And so URI is the technical lead, and I reached out to some colleagues at Tufts University and also the Norwegian Geotechnical Institute in Oslo. And that constitutes our group. And I have about 20 slides, so it's not too long a presentation. And this is what I'm going to talk about. I'm going to acknowledge the role of CRMC in these efforts, which we couldn't have done any without. The research environment. I didn't think this would be necessary to do a super technical talk, so I wanted to talk about how the regulatory environment allowed us to do this, which is frankly, I think, pretty unique and pretty special. And then talk a little bit about our projects that are going on both at Block Island and at the Coastal Virginia Offshore Wind Farm off of Norfolk. And then I'll finish with some concluding remarks. And please stop me at any time if you have any questions. Happy to answer them. So don't need to go crazy about this. Long list of acknowledgements from Norway. And the key thing I wanted to point out about this is we've had tremendous help from both Ørsted, the developer at Block Island and at South Fork, Dominion Energy at the Coastal Virginia Offshore Wind Energy, GE, who maintains the turbines at Block Island, Siemens Gamesa, who maintains the turbines at CVOW, and a whole host of students, graduate students and undergraduates at both URI and Tufts. And so really, we've put together a really large team and have gotten tremendous support from industry, which we would have been dead in the water if they hadn't been on board with this. So Jeff mentioned a little bit about the history. I want to give you the history, how we see it. So it all starts with the Ocean SAMP a long time ago, which was a tremendous effort to help site Block Island and provide scientific data to help Deepwater Wind at the time make some decisions about that. URI, under my colleague's leadership, Stefan Grilli in Ocean Engineering, went after a $20 million proposal in 2012 to fully instrument and do all sorts of interesting things with the Block Island Wind Farm. And we got rejected. That got turned down. But it planted seeds both within CRMC and it planted seeds within the Bureau of Safety and Environmental Enforcement and the Bureau of Ocean Energy Management. And so if you skip a few years, I'm sort of looking over here, you skip a few years, 2016, Block Island becomes operational. And we were asked to submit some white papers. Grover Fugate and my former colleague, Malcolm Spaulding, solicited a bunch of white papers. A bunch of us submitted topics, everything from desktop studies for gravity-based foundations to structural health monitoring and lots of other stuff in between. And we sort of just sent them out into the ether, sent them out to BOEM and BESI. And lo and behold, about 2 years later, BESI came back and said, we're really interested in structural health monitoring at Block Island. Do you think you could do that? And we said, we hope so. And we started a conversation. We technically, we could do it. Question is, could we get permission to do it? And there's, you can see sort of the timeline there. And I wanted to point out how we've been thinking about this since 2012 and earlier, since 2008. And sometimes it takes a long time and a lot of people to get these ideas off the ground. And this project, or these two projects, really have exploded and been leveraged into many other projects. So if we take the Block Island project, which comes from BESI, gives money to CRMC, which then passes the money on to URI and then to our colleagues. We've gone after funding from our Tufts group has gone after now RDC, which is the New York NYSERDA funding program. We've gotten money from Mass CEC. We've gotten money from the National Science Foundation. So this little project at Block Island has really blossomed. And if I show one more slide on that, to date, we're up to we got $600,000 from BESI to work on Block Island. And it has turned into $5.7 million in funding from a variety of different sources and a couple of different projects. And we're talking with BESI now about continuing that work for other wind farms like South Fork, like Dominion Commercial, things like that. So it is really growing, and we have a lot to be grateful for CRMC. Now, how did we get that? What role did CRMC play? Well, they were at the very beginning, and in the regulations, in the permit for Block Island, there was this stipulation, which is just one little stipulation in the number 14 that talked about research. And because my understanding is because Block Island was in state waters, CRMC had some leverage or was able to discuss with Deepwater Wind about what other uses could be used for this first demonstration project. And this stipulation was put into the permit, and it's brilliant. It opened the door for us to talk to Deepwater Wind. We had to convince them, and then we had to convince Ørsted that our plans were sound and that everything would work and develop that trust. But this stipulation opened the door for research, and under no circumstances would it have worked if we didn't have this. So this was really, really a brilliant thing. Bohm and Bessie took notice. So when the Coastal Virginia Offshore Wind Farm, the pilot project, they've installed 2 towers about 26 miles east of Norfolk. When Bohm issued the permit, they added a research stipulation to it as well. And I think they were heavily influenced by the experience we had at Block Island and from CRMC. So I wanted to say thank you, because this work wouldn't have been possible without that foresight in adding research stipulations to these early wind farms. The reason Bessie is so excited about this is because they're facing a challenge, both Bohm and Bessie. You know, they have a lot of expertise in oil and gas and in offshore and other energy development. They are learning on the fly with offshore wind. And so they've ramped up their staff. The fact that they can have teams of researchers doing research on these small scale wind farms builds up their knowledge base quite a bit. So we have a very good relationship with both Bohm and Bessie. And that relationship is centered around these 2 projects, the structural health monitoring projects. One at Block Island, which formally ended last year, but continues. We're still collecting data. And as I mentioned, one at CVAL. We're getting a lot of attention, not just within the state, not just within the technical community. That magazine on the right, that's a cover of Engineering News Record, which is a very old, reputable engineering magazine. And I still get it. And I got it in my mailbox last year or 2 years ago. I looked at the cover. I said, ooh, ENR is finally on board. They're covering offshore wind. And then I said, that looks like an Atlantic Winds crew transfer vehicle. I said, wait a minute, that looks like Block Island. I said, wait, that's my colleague, Babak Movani from Tufts University. So I don't know how he got on the cover, especially since I'm the one who took that picture. So he must have liked the picture of him better than me and submitted it. So we were thrilled to be on the cover of that magazine. But on the technical side, the objectives of our structural monitoring projects are to look at things like modes of vibration, looks at stresses and strains. I'm a geotechnical engineer. I'm a civil engineer by background. I care about soil behavior and permanent deformation and all that kinds of stuff. So soil stiffness and damping, and then assessment of fatigue in the structure. From a Bessie point of view, this is what they care about. And it all wraps up together. They're very interested in design verification, right? So they, again, are ramping up their knowledge base. They want to know, can our measurements verify the design assumptions for these wind farms and whether the assumptions are valid, whether it be for wind conditions, loading, scour, and the like. Predictive maintenance. If we make measurements, can we identify from some measurement when something needs to be replaced or something is out of whack in terms of the turbine behavior? Can we use that information in a predictive manner? Maximizing annual energy production. That's really for larger wind farms. The goal there is, as we move to commercial wind farms, and if we are instrumenting certain towers, can we measure the wind conditions on the first row and use that information on the last row to either to better capture the wind that might be occurring. So that's sort of an operational thing. And then sort of the big one that we're interested in is service life extension. So when you make assumptions in design, especially on the East Coast, especially when we're in a new environment with hurricanes, which are different than the conditions that they've seen in Europe and the North Sea, there are assumptions made during design about the loading and about how many cycles of load these structures can take, and they're designed for a certain period of time. our belief, and I think we're showing it, that with careful instrumentation, you can actually say, yeah, it's not being loaded as much as we think it is. And the goal there is to ultimately extend the life of these structures to deliver more power longer.
Just quick.
Yeah.
Service life extension, is that strictly the structure, or are you looking at the equipment inside the the actual turbine itself and the electronics?
Yep, so for us, it's the structure.
Right.
The turbines, that is actually a very interesting problem that is industry-wide, right? The turbines are getting so big. So that is a question, so let's say 25 years from now, these towers or CVOW or there's determinations that sure enough from proper structural monitoring, we could extend the structural life of these. What goes on there, right?
And that would be part of the service life extension.
Yeah.
Would be the upgrades on the power plant, basically.
Well, it would be, so you have to make, at that point, the question will be for the industry, what's the size of the turbines? I will say, since Block Island was done in 2016, I think the size of the turbines has more than doubled. So, Vineyard Wind is more than double. So that becomes a real issue, right? Can you put 30 years from now, could you put, I don't know what size turbine on these towers? And the answer is probably no. So does the industry have to come to some agreement, or just, that's an industry-wide decision at some point.
Technology allows it to get smaller.
Maybe something, but I think on our side, the goal is to assess.
I don't mean to prolong it.
No, that's okay. I like talking about this.
I'll prolong it. But you asked my question about the size of the turbine, because they are at 14.
Yeah.
And NYSERDA just lost its ability to expected 18 megawatts that GE was supposed to deliver for some of their proposals are now going to be a more mature 14 megawatt.
Okay.
So you answered my question on whether or not these might be able to handle that, and maybe Don's correct. The technology makes them lighter.
I'm sure it will.
But my question is, and it might be too early in the research life.
Mhm.
You have Block Island that has the derrick structure, four legs.
Yep.
You got Coastal Virginia, that's a monopile.
Yep.
Are you seeing differences already in the short amount of time you've been researching, of which of those might be more structurally healthy?
Structurally, they're very different. The jacket structures at Block Island are very stiff. Part of that is the soils we have, right? The soils at Block Island are glacial terminal moraine deposits, right? That's the southern extent of the last ice age here. The glaciers came out to Block Island and Long Island in that area. So the soils are very stiff, which is one of the reasons they probably went to those smaller piles, because they could get them in. And the jackets themselves are very stiff. The monopiles are very flexible, right? They're like flagpoles. And so they're designed for that, but they do vibrate a lot more. The monopiles create more noise, not a lot, but the Block Island towers are really quiet from a noise perspective. So from a health perspective, the answer is one's not better than the other from a service life. The key is to measure the loads and then revisit the assumptions. And if Block Island was designed for a 100-year hurricane, for example, and we can demonstrate that it's never seen close to that, then you could extend that structure. That's the argument. And I will say the trend right now along the East Coast is clearly for monopiles, right? So they're bringing steel from Europe. I think they're trying to fabricate a monopile facility in Philadelphia, I believe. But the future right now is for monopiles, except from a soils perspective, there are some very challenging soils that a number of developments are finding, a soil called glauconite. We could talk about that for a while. And that is causing a lot of heartburn for the East Coast offshore wind industry. And it might push more companies or more developments to things like jackets or some other structures. In the Gulf of Mexico, they would probably use jackets because they have a huge knowledge base down there. So the choice of foundation depends on a number of things. Jeff, does that answer your question?
Yes, it did. Thank you.
Okay. All right. So these are the sort of the overarching goals that Bessie is interested in. And one of the big things, I thought I would just mention this, although we're talking about measurements, there has to be a strong modeling component. And this is a very trendy term these days called digital twinning or digital twins, where we set up a digital model of all the towers that we're monitoring. That model makes assumptions about material properties, about loads. And what we do is integrate the measurements that we are getting at certain points. So if we're only measuring accelerations at, say, 4 points, but we really care about fatigue in the jacket lower down, we can use measurements combined with our models to essentially have virtual sensors somewhere else on the tower. So if we're worried about hotspots somewhere else, a good digital twin will get us that. And from the digital twin, we can infer wind loads, we can infer all sorts of wave loads, all sorts of things. So it's a hot topic right now, and I think any kind of monitoring program needs to have a strong numerical component to sort of boost it. A little bit more about Block Island. So this is what we've done out at Block Island on Tower B2. We've done an installation campaign where we installed accelerometers at 4 levels, and out on the deck, we installed inclinometers to look at tilt, and we've installed strain gauges. So the accelerometers measure vibration, modes of vibration. The strain gauges that we put at the base, so there's some strain gauges down here, they measure the forces, and we can back out a lot of information about the forces on the tower. And then inclination measures tilt, which is a big issue for things like turbine health. If the towers are tilting, then the turbines themselves have very tight tolerances. Just a couple of pictures. This is what some of that stuff looks like. So these are accelerometers being mounted inside the tower. We used wireless and wired. These actually didn't work so well, but we were trying them out. It's a massive undertaking to run cabling up inside these towers. These are really amazing structures on the inside, and when you go to the top of them, they're pretty dramatic. So those are the accelerometers. You can also see the bolts. These are not trivial bolts. The biggest bolts are almost 2 inches in diameter. These are large structures. And then strain gauges, again, measure the force. So we've done a lot of strain gauge. You can see again what it looks like on the inside down at the base of the tower. And these are the strain gauges. You essentially microspot weld them to the inside of the tower. Again, you need the trust of Ørsted or Deepwater Wind, and to be allowed to do that. And so that takes a lot of training, a lot of effort. Thankfully,
Would it be easier to do this while they're being fabricated and before they're installed? And is that being done?
It is. So it is being done. Sometimes it depends. So for example, Ørsted at the South Fork wind farm, they ordered up one of these instrumentation packages in the yard in Germany. I don't know if it's in Germany, but so you can install instruments ahead of time. And at CVOW, they did one set of strain gauges ahead of time. So this is sort of a post-construction. This is actually cheaper. So the Norwegian group that we work with does this a lot. And so they talk about this as being like a doctor's kit. So although we're doing it post, it is a little bit cheaper because they're already installed. You don't have to worry about them surviving installation and all that kind of stuff. So there are some advantages to this. What you don't get is the full record of from day one, when they plug them in. So that is a good point, though. Just a few more pictures. So again, I'm always impressed when we go inside these. This is the power cable for Block Island B2. This is an elevator shaft and a ladder. So we can fit 4 people in the elevator under tight conditions, because you don't want to be going up the ladder that often. It's a really when you're running the cables with the ladder, it's a lot of work. But they're amazing structures. And so since I think 2019, we've been collecting data. The data for Block Island actually has been really nice. We get a real-time stream of data. This looks terrible, but this is what it looks like. So we could log in to a laptop computer that's sitting in their control room on Block Island, and we can pull in data in real time. We've been asked when we had the 4.8 earthquake in New Jersey, we were asked by BOEM, did Block Island see it? We could look at it within a couple of hours and say, yeah, Block Island didn't know it. We don't see any of that in the record. Whenever there was a storm, the storms in December, same thing. Did you see the storms? What are the loads on the tower? That sort of thing. So we can quickly analyze some of that data. I think I'm going to bore you with some data. So I'm just going to show you a couple slides of this. This is what the data looks like. These are accelerometers at the top of the tower, all the way down to the bottom of the tower. Just a lot of vibrations. We're collecting this at 50 measurements a second since 2019. So it's a lot of data, but this is the kind of stuff that we get from it. From it, we can look at, this is the important figure. We can look at the natural frequency of the tower, right? It was designed to be about 0.29, I think it was. And we can measure that. We can look for shifts in the natural frequency, which might indicate damage or some other thing going on inside. And so we get a lot of information by looking at sort of the frequency data from the accelerometers. From the strain gauges, we can do a whole bunch of stuff. The figure on the right shows the stresses. So this is the stresses on the tower as a function of wind speed. And one of the very interesting things is you think about the towers and you think about what's the worst case scenario, might be a hurricane. Actually, turns out it's not hurricanes. It's, as you see, as the wind speed increases, this is sort of the rated wind speed at about 11 meters per second. That's when they've got the blades out, they are producing maximum power, and there's a lot of stress on the towers. As the wind speed gets higher, what do? They feather the blades, just like a sailboat, and the loads actually go down. And actually in design storms and hurricanes, they will actually feather the blades, turn the nose into the wind, and the stresses are lower. So it's a kind of an interesting thing. And the worst case scenarios, from an operational point of view, are actually sometimes when they start and stop, they turn the blades and sort of shock the system. Those tend to be our biggest loads that we see. And then the scenario that BOEM is interested in and they worry about is what happens if there's a hurricane and they feathered and they're into the wind and the power goes out and the wind shifts and sort of hits the tower broadside. And so there's a lot of talk about that scenario, but we certainly haven't seen anything like that. But we can learn a lot from this. Yes, sir.
Based on the data you have, would you have made any design changes if you knew this information before you actually designed one and in the ground?
We're not looking at it from that. What we're looking at it is knowing these loads, these are lower than what it's designed for. So could you make the tower a little differently? Maybe, but hindsight's 2020, right? We didn't have these measurements ahead of time. Right. I think the real benefit of this is to saying, we have there are fatigue analyses that say this thing's going to undergo, for example, 1 million cycles of loading. And if we can demonstrate that it's only, half that, then it's got some reserve structural resistance. I think that's really the lesson that we're trying to learn from it. Thanks, Doug.
It seems as if one of the things I used to have to think about was a design to cost type of thing. So you want to be able to, are there places where you can reduce the cost of the structure and assembly?
Mm-hmm.
If they're overperforming, do you use that? Where are the cost drivers and stuff? So I'm not sure. The database you've got, maybe somebody should be looking at it from a design to cost standpoint. Yeah,
no, I will say, certainly Ørsted, who is the largest offshore wind company in the world, they know this stuff. Yeah. And they designed the tower at CVOW, and that tower has several sections in it, and it changes by millimeters because they're trying to save steel. Okay. So they are very careful about that, especially Dominion Energy is going to start building 176 of these starting this summer, I believe. They're trying to start installation. So they care about this the cost, and any of this knowledge would greatly.
I'm not sure on the communication link.
Yeah.
You've got the database. How do you get it out there? Do they actually take a look at it?
Yeah, so Ørsted's a partner with us on this project, and we meet with them about this and CVOW, and there's a couple in the North Sea that my colleagues at Tufts are working on with them. So we work with them quite a bit, and they're particularly interested in what they find value from our group is this idea of this doctor's kit. If you can go in and slap some instrumentation on, it's the wrong word, it's fancier than that, but if you install some instrumentation, make these types of measurements, then they can learn it. So that's where they see our interest. And then the corresponding digital twinning, the numerical modeling,
Yeah,
they're
that's
very,
good, yeah.
they're very interested in that as
Yeah,
well.
that would be a good thing to play with, I think.
Yeah. Yeah.
So. Do you get involved at all with a power purchase agreement type thing, trying to?
We do not.
No,
We can, no, we do not.
no. I read a month or so ago, and I don't remember the state, but it was down south. South Carolina, down that way somewhere, and I'm not sure their projects. But they decided that they would not have any turbines at all. They're gonna go with nuclear power plants.
Okay.
And I'm not, and it was, to me, it had to be a purchase power thing where the nuclear was a lot cheaper than the turbine, and it's kind of fuzzy, but I was kind of surprised to see that.
Yeah, and I don't
It
know.
wouldn't sell up here, I don't think.
No, I mean, there's many issues that have nothing to do with the technical side,
Yeah.
right? But I do know on the technical side, further south you go, the higher that the risk is from hurricanes, so the loading becomes more of an issue.
Okay.
So that could be part of the calculus, right? You know, the storms that North Carolina faces and South Carolina face are different than the ones we get.
Well, I'm glad, you know, that the data up here
Hmm.
indicates that we can certainly handle our conditions up here.
And we are instrumenting Virginia. So this project, all these are public slides. The Virginia project is still under an NDA, so I can't show you those, but we're doing very similar work down in Virginia and Dominion Energy. I like working with Dominion Energy. They're a US energy company and they are very interested. They're like BOEM. They want to learn, you know, Ørsted knows a lot about this subject already. Dominion is learning a lot and is committed to a large wind farm. So they've been a very good partner to work with as well.
Very interesting.
Thank you. I think actually, I probably only have one more slide. I did want to just point out my colleague, I only show this picture because this like pulls out the old drafter in me. My colleague Eric Hines still thinks like this and he draws beautiful drawing. These are his engineering calculations for some loads, calculating the loads on the tower from some of this data. And I show that to my students and tell them to do better because that's a pretty impressive engineering sketch. That is old school. Anyway, so just a couple of concluding remarks. So I made the point at the very beginning, the regulatory environment that was set up for the permits for Block Island Wind Farm made all of this possible. If it wasn't for that research stipulation, Deepwater Wind never would have talked to us, or it would have been difficult to talk to them. And same with Ørsted. And then once we gained the trust, then they became very, very valuable partners and have been really wonderful to work with. But it's really from CRMC's efforts with Block Island that have made it very useful and very possible. We're continuing to do work at Block Island and Seavow, and we're talking with Bessie about and Ørsted about possibly expanding that work to South Fork. So the work continues. And just a plug for URI in general. We're doing a ton of work on offshore wind, not just me. So I'm heading the group on structural health monitoring. My colleague, Jim Miller, does a lot of acoustic. He has measured the installation of all 4 wind farms in the United States and monitors noise. We got a lot of people doing floating offshore wind work, innovative foundations, anchoring systems for wind, and a lot more. So it's a really exciting time to be working on offshore wind at URI. And I'll just finish with showing my students. What do you do when there's a great construction project? You take them out on a field trip. So, you know, that field trip happened in the middle of the summer when they were installing the last tower. And literally on a Monday, I said, I rented a 50-person charter boat out of Galilee and said, I sent an email on a Monday in July and said, who wants to go on a field trip? Middle of the summer. And I had a waiting list of like 20 people by Tuesday. And so the students just all came from everywhere. And we had a great day watching that construction.
Good.
So with that, I'd say thank you very much.
These sorts of towers have existed in Europe for decades.
Mhm.
Are they doing similar research to this? And do you think that are we going to uncover anything different from the type of work that they've already done?
The answer, so
They get high winds. I mean,
they have high winds. They don't have hurricanes, so their
they get
designs,
hurricane force winds.
their designs are less than the designs in the United States on the East Coast. So there are different loading conditions.
Okay.
Wave loading is different as well. Maybe not so much for Block Island, but certainly the other wind farms. The wave loads are bigger offshore than they are in the North Sea, where it's relatively shallow. Companies like Ørsted have a lot of this knowledge. I will say that knowledge is all proprietary and they don't release it. They never release it, or they don't release it. One of the objectives with Bessie was to get some of this data out into the public sphere. And so they wanted to fund projects, which, although we're under an NDA, there is the expectation that we will, we share our papers with Ørsted or with Dominion Energy, and we go through it with them, and then ultimately we publish this. So Bessie wanted public data in the public that they could look at, that other researchers could look at, that could help the industry as a whole, instead of just the wind companies that hold on to this themselves. So some of this is not new. The digital twinning is pretty cutting edge. So combining this with the numerical modeling is pretty new. And Ørsted's very interested in that aspect.
They have not done that.
They have not, I think they are learning how to
They
do
wouldn't
that.
tell you if they have.
No, everybody is trying to do it now. But we have a good group doing it. So, and Ørsted's part of that group. So they're interested enough to be working with us on that. Yes.
Are the structures recyclable, or is there a turbine graveyard somewhere?
I can't speak to this exactly, but I think the first wind farms in Europe are just now at the end of their service life. So Europe is now facing that issue of the oldest wind farms. What do they do with them? Do they cut them off below the mud line? Do they add, we have this issue where the oldest wind farms in Europe have really small turbines now. Nobody makes those turbines anymore because they're making 14 megawatt turbines now. So there is an issue that Europe's facing. Thankfully, they're ahead of, this is the one aspect where it's good that they're ahead of us. They've got to figure out, do they reuse the structures? How do they get them out of the ground? Do they leave pieces in the ground? I think Europe is facing that right now.
They're redesigning the fields so that the ones that were, let's say they had 100 turbines, now they can get twice the power with less than half the number of turbines.
Yep.
So they're upgrading that way too, where
Yep.
there's less impact and more power. And then they do have a whole pile of them to get rid of somehow, right? Maybe.
Yeah.
Sell them, find out maybe, or whatever. Great steel.
Chris, you talked about galvanized cements earlier. Will this research help determine whether or not certain type of technology can be used in galvanized sand? Because right now, it's pushed turbine locations away from that material.
Yeah, so this research will not do that, but so the issue with these glauconitic sands is that they're kind of like M&Ms. So if we had a handful of them, they look like sand. And then if you disturb them, like drive a huge monopile with a big hammer through them, that outer shell breaks and they turn into a really sticky clay, which makes driving the piles really hard. So and the worst thing about, the thing people hate most about the offshore environment is uncertainty. So if they need to drive a pile, whatever it is, 30 meters into the ground, they got to drive it 30 meters. And if it gets hitched up at 26 or 25 or something, that's a real problem. So the issue with glauconite is, can you install piles? And so everybody's trying to figure that out. And in that uncertainty, one of the things they're saying is maybe we move the location, which I think you just alluded to. Maybe we think about a different foundation structure. Maybe instead of going down 30 meters with a big monopile, maybe we use suction buckets, or maybe we use gravity-based foundations, or maybe we drive smaller piles on jackets because we have better confidence that we can get it through that stuff. So it's really, this does not address that, but that is the big geotechnical issue right now.
And that's where I was going, because we have finite lease areas in
Yeah.
the Rhode Island energy area. And there are open areas of those lease areas for a number of reasons. Like Don said, maybe the technology has just driven 100 locations to 50. But it's also because of the material they're driving it into, but it still allows for that space to be used in the future. So I'm just trying to keep an eye open and an ear open, quite frankly. I have another question unless council members do. You mentioned Ørsted throughout.
Yeah.
As a partner here, but there's a number of other developers out there. Are they not interested or Ørsted is just willing to pony up?
Yeah, so right now our contacts have gone through Block Island, and therefore it's been Ørsted. And that has grown. The other developers, other than Dominion Energy, that's the other one that we've been working closely with. So just those two right now. You know, we would love to do more.
So you haven't heard, like they haven't knocked on your door or?
Nobody has knocked on our door. Nobody has knocked on our door. But I did mention Bessie is interested. So we're talking with Bessie about potentially doing the same thing at South Fork. We're talking Ørsted about the same thing at South Fork. None of that's decided yet. So that's all still, we're just talking about that.
Will that lead to Revolution and Sunrise since they're Ørsted projects?
I would love South Fork. That's one thing. That would be amazing.
No more questions, sorry.
All right.
Do they have general symposiums where the various companies come together?
I didn't hear you. I'm sorry.
Yeah, I asked if we're involved with various symposiums where the different companies come together to show and tell and presentations and those types of things where this presentation like this would hit multiple groups. Is that happening?
That happens a lot. So in fact, they range from very technical. And so digital twinning workshops, there's a digital twinning workshop in May up in Boston that we'll be presenting at. I can remember, I pulled a couple slides. The slides with the regulations, with the research stipulations was a talk that I gave to an industry group 4 years ago, talking again about highlighting how we could do research and how the research permitting really enabled it. So yes, the answer is lots of symposia.
I would think your modeling, you know, is a very marketable item, and you may be way ahead, I hope.
It is, but I will say this data set, when I talked to, and I've forgotten who the group was, a German group. I talked to a German group that we have a lot of contacts with through URI, and I showed them something like this, and they were like, how did you get that data? And we cannot get that data. That data is not available in the world. So the data is valuable for researchers. You know, maybe there's somebody who's a lot smarter than me who could do something special with this data. And that's our goal, is to get it out there. So
you really need that interface.
yeah. So we're definitely,
Symposiums.
we're definitely doing that.
Yeah, it's a big cocktail hour at the end of them. You do a lot of business for about an hour.
You may have already mentioned this. Are all of the turbines at Block Island, are they all monitored or is it just one?
Just one.
Just one.
So just the second one, B2. There was a good reason for that. I mean, it was the first time we did it, and they actually have a fiber optic line running from B2 back to the island. So that made our data transfer very easy. CVOW, we have both towers, and potential future ones would have more. But yeah, we only did the one for Block Island.
So the point of this is not to look at, say, a group of 5 turbines like that and see, are any of them under more stress than the others that might risk failure at some point? And you could see that by the numbers, because you'd have to monitor all of them for that.
So that's a very interesting question. It turns out, because we've had such good partnership with Ørsted and with Dominion and with GE and with Siemens Gamesa, we get what's called the SCADA data. The SCADA data is the towers are instrumented, right? So GE owns those turbines. Ørsted owns the tower. So GE gets this data off of their towers to measure their performance. So they have accelerometers in their turbine, and they don't give that to anybody. We have access to that. It's under the NDA. But what we're able to do is, if we have one tower that's instrumented well, and we're measuring everything, including the SCADA data that GE is giving us, we can use machine learning. We can use machine learning to learn about the other towers. So we can absolutely predict things like power production. When the wind's blowing from the southwest, we can see that B5 is getting more power than B2, and we can see that reflected in our instruments. And we can predict performance using machine learning and AI. We can predict performance in the other towers based on ours and the numerical model. So the goal is not to have to instrument every tower in a wind farm. It's to pick and choose the optimal, maybe the optimal number, instrument a couple of them, and then use the sparse data that we have to do a lot of work. So it's really, that's the sweet spot.
Makes sense.
Any further questions?
Thank you. Thank you very much.
Thank you.
Thank you very much.
My brother was in World War II,
Okay.
and when he came out.
Yeah.
That you couldn't get a job. So when all of a sudden somebody had decided that GI Joe would be a good thing,
Yeah,
and so he ended up at URI, he became a civil engineer.
nice.
And I asked him why the hell he did that, he said it was the shortest line.
The shortest line?
When he got involved with early designs on the Sylvester of the Bridge,
Okay.
and in his nineties, I used to bust his ass because they had to tear the bridge down because it corroded on it. I could light him up pretty good. It was 92, 93, still get upset. But he did go, he ended up, I don't know, by the time I was going to college, he ended up going back to Rensselaer. He got his master's and a couple of E's. There's a combination, right? He set the line for civil engineers, in the late 40s, wasn't very long.
Wasn't very long.
So, your background was forget that.
Yeah.
Thanks.
All right, thank you.
Thank
Thanks,
you.
Jeff. You're very welcome. All right. Take care.
All right.
All right, at this time, having nothing further,
Oh, yeah.
Sure.
motion
drawing.
been made to adjourn. Is there a second?
Second.
Motion made and seconded. All in favor, say aye. None opposed. Meeting adjourned.